everyone, welcome back. We are now going to start the 5th lecture of this series, and as you remember, in the last lecture we tried talking about the data aspect of recommender system. In this context, we saw what are various rating scales and we continue after that. Specifically in this lecture, we are going to talk about the data description part. When we talk about the data, data can be structured or unstructured. Structured data is organized and it is very easy to work with, and it can be conveniently brought to numeric form, which can ultimately be used by the algorithm, whereas you have to little work extra on unstructured data and bring it to a structured form so that it can be used by the algorithm that you are targeting to. Consider this case. This is the data about movies, specifically from movie lens data set. This is the data about movies. This is the data about movie. This is the data about the user, and this is joins movie data with user data. Let us look at the nature of this data and in which kind of rating scale it is in. Look, movie ID is, of course, we studied about 4 types of rating scales: nominal, ordinal, interval and ratio. So, obviously this is a nominal. This is also nominal because this is name. But if you look at this, in this data there are 2 parts. One is the name of the movies and the year of release. So, therefore, when we have to process this data, we have to probably separate these 2. Similarly, look at the genre of the movie. These are the 3 genres for this movie. Now, if you have to work upon, probably we have to represent it in a different manner because these are basically text data. Okay, so now come to the user. Similarly, user has user ID, which is again nominal, gender is also nominal, age is in ratio scale, and occupation, which is again a nominal, and zip code is also a nominal value. Coming to this user ID combination, we have rating data as well, where for a specific movie ID, how a user 1 has given the rating. Now, to bring it to some processing convenience, what we are supposed to do? Let us say this is our model. We will be giving some data as input and we will be getting some output, let us say some class as our output. So, this input data which goes into the model, what is a model after all? Model is basically certain computational function. So, it is a kind of function, very complex function that you will be building. Nature of the function can be anything. Now, when you give input, this input has to come in numeric form, and how to convert this data to various numeric form to, let us say, adventure, children, fantasy. Suppose all the genre you will be, let us say there are total n number of genre, 1 to n number of genre. So, wherever it is 1, let us say this belongs to adventure, this one belongs to children's movie, this one belongs to fantasy. So, probably we will be making this 1, this is as 1, this is as 1, and rest will be zeros. Okay? So, that is how we will be making a vector to represent genre. Okay. So, now let us go. This data was pretty structured. So, we can even think of that representing this name as instead of name we can use movie ID, and later on whenever required we can connect it. User ID is of course this is also nominal. Rating is anyway in a ordinal scale. And now comes to this adventure, comedy, etc. As I told you, we will be representing it in the form of this kind of vector. Okay. Let us go a little bit more deep. Let us say some movie, Jumanji, and we have got this data that was from Movie Lens, and we have got this data from IMDb. Of course, I have given certain snapshots of this the IMDb website. So, it has certain rating, then certain popularity score, cast and crews, you can go into detail. Besides that, it will also give you what kind of genre it is, who is the director, writer, leading stars, and this is a short description which is in text. How do I convert this data into numeric? Similarly, look at this. It has many user reviews, and user reviews are detailed here. So, there are total 324 reviews, and this is just one of the reviews. This writes like among the thousands of films, blah 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 blah. So, which means this whole thing now I have to bring to certain numeric form. So, what is that numeric form in which I will be using this, and where I will be using this? Suppose if you remember, in the basic form, the matrix there are three matrices. One is the user matrix which provides the user demographics, then we have item matrix which provides item features, okay, and of course we have the rating matrix. Now, this is one item. Jumanji as a movie is one item. So, there are many features which you can directly consider, like say who is the director, the genres, and so on. But there are certain features which are supposed to be extracted from this text data. This is one, this is one. So, we have to have adequate procedures to convert it from numeric to text data. So, one of the form could be you can have some kind of matrix in which the total, if you have this is movie along with the explicit features like that of genre, etc. You also have few more values corresponding to this text data. Okay. What could be the value? Maybe there are certain important terms which are used frequently. So, maybe that those terms and corresponding TF IDF rating, which we are going to discuss shortly, we can use. Similarly, in case of reviews, we can find out what is the total positive sentiment and what is total negative sentiment. So, sentiment can be another important criteria to define the feature. So, whatever may be the case, we have to ultimately bring the data into numeric form. So, when we bring the data into numeric form, the data, let us say the data that we consider, let us say this item detail, which has items maybe here I1, I2, etc. Let us say there are m items and there will be many features. Okay. So, what are these features? Features are individual attributes which will be describing the data. So, we must know what is the characteristics of each of these features. Now, when we talk about the characteristics of a particular feature, as an individual feature, we can find out certain descriptive statistics which in a univariate way describes the data. And because there are multiple features, comparing them also we can derive certain statistics. So, basically descriptive statistics are brief descriptive coefficients that summarize a given data set. So, individually if we look at each column, it involves describing the distribution of individual variables. So, when we talk about this particular variable, as we know this can be in different scales, and what is the corresponding descriptive statistics, that also we saw. But for the time being, let us make it a little bit generic and let us see this data is numeric only, quantitative data. And in fact, all the data that will be fed to your algorithm has to be brought into a quantitative form. Quantitative in the sense, even if it is a data which represents a nominal attribute, it also has to be represented in the form of a numeric form. Just like we saw in case of genre is a nominal value, but we represent the genre in terms of a 0, 1 vector. But anyway, for the time being, let us look at what are various univariate analysis that we must perform to characterize the data. Let me tell you, this particular course is on recommender systems. Therefore, while discussing about these basic foundational aspects on statistics, maybe something on matrices and all, as well as machine learning, I will be limiting myself to only basic concepts. To go into in-depth details of those topics, we have to be referring to books or other online resources. Okay. So, let us go ahead with univariate analysis. Okay. So, measurement of central tendency, as you know, can be done in using three different statistics. One is mean, median and mode. These are the measures of central tendency. So, this you already know. However, I have to make little bit aware, I have to make you aware of little bit more details. Consider this particular data. Okay? And this is mean, this is median, this is mode. What is median? The mid value. Mode is the highest number of occurrences of something in this data string, some element in this data string. Now, look at this. Suddenly, we have added one more very large value in this list of data. Now, if we look at mean, median and mode again, we look at this mean value has increased, but this one may be one outlier. What is an outlier? Some value which is unexpectedly high or low, and that cannot follow this particular distribution from which these values are drawn. Let us say this value represents age of certain person. So, age of certain person being 517 is almost impossible, but consequently because of presence of this has increased. So, therefore, in many situations you are supposed to keep track of, you should not be blindly following the mean value if you are trying to understand the nature of your data. Here in this context, median is a better representative. Similarly, talk about mode. If the data is nominal type, mode makes sense. Suppose this data is in nominal scale. So, in that case, median also is also not so important, in the sense it does not make any sense, and mode is the important thing. Suppose this data is in ordinal scale, then median takes important place. But in case the data is numeric, then also you have to be taking care of this mean, median and mode and observing how the mean changes with respect to this median and mode. So, the point that is being made here, the median is less sensitive to outliers, okay, to more than mean. So, thus if you would like to understand whether your data is being skewed, skewed means tilted to a particular either to the left or to the right, then you have to be comparing mean and median. Now, next thing is the spread of the data, starting from which point as the minimum value, which point as the maximum value, and how it spreads. So, this is again there are many terms, many to characterize this dispersion or spread. First one is range. So, range is the range which is the difference between the largest and smallest value in the data set. So, range is something which is the difference between the smallest and largest value in the data set. Variance. So, variance measures the fluctuation of the observation around the mean. The larger the value, the greater is the fluctuation. And standard deviation, as you know, it is the root over of variance. So, in this particular context, we have considered the sample variance. As you know, there are two concepts. One is the population, which represents the entire data about something, and sample is a very small part. So, whenever we are using sample, instead of using n, we will be using n minus 1. Okay. So, with this, now this range that we consider, that can be broken into 4 quartiles. So, this lower quartile, this is connected to range. So, this lower quartile Q1 is the value such that 1/4 of the observation falls below it and 3/4 falls above it. And similarly, median is the middle value, Q3 is the other part, this side Q1, Q3 is the other part. So, this interquartile range is the difference between the third quartile and first quartile. So, if you look at this, this is the data, this is the minimum value, this is the median, this is the maximum value, median is the mid value. Then if you take this part of the data and make it again into 2 parts, this part makes your first quartile, the middle of this is first quartile and middle of this is the third quartile, and we have actually made the data into 4 different parts. Okay. So, here the range is this, standard deviation as following that formula, and variance etc. Now, this is something called a box plot. When you look at the data feature wise, one of the approach in which you can have a visual representation to comprehend better is a box plot. It is a box and whisker plot. These two sides are called whiskers, and there is a some value in the middle, there is some line, this is the median line. As you saw, median is away from the mean in this particular diagram. Of course, this is not corresponding to this data. So, median is little bit away. So, to this side. So, what does this indicate? The data is been little bit skewed. Okay. So, now this is the minimum value, this is the maximum value, but there are some values which are beyond minimum and beyond maximum. What are they? They are called outliers. So, what are the outliers? Any value which is larger than Q3 by at least 1.5 times the interquartile range, or smaller than Q1 by at least 1.5 times of IQR, are termed as outlier. Now, look at this. In case of understanding univariate data, we have considered its central tendency, its spread, and while talking about the spread, we also understood that we have to figure out whether the data, there are certain values where higher importance is given, or for example, let us say an user's rating you are trying to find out. Let us say this is rating 1, this is this many times rating 2, these are the ratings and this is the frequency, how frequently he has rated. This is rating 2, then this is rating 3, 4 and 5, 3, 4 and 5. So, which means this person mostly gives a very low rating to whatever he rates. So, such kind of observation can be figured out if we study the skewness of the data. So, skewness measures the asymmetry of the data. Of course, here the figures that you see, they basically are for quantitative values like in the ratio scale or in the interval scale. But as I told you, through a histogram also you can study for ordinal scale as well as for ordinal scale where the order also matters. So, now here this particular thing is called negatively skewed and this is positively skewed. So, if it is positive or right skewed, you have a longer right tail, and if it is negative or left skewed, you have a longer left tail. So, you have a longer left tail over here, and if you have a longer right tail over here. And this is the formula. Formula of course is not important. All the things that you do, probably you will be using certain software or you will be certain language where all these codes will be available to you. So, the formula anyway you will build it. So, why exactly do you need to study? Because you will be understanding the practical aspect of what is the nature of the data. So, therefore, understanding all this is very important. So, how peaked is your data? So, if look at this data, here the spread might be same, okay, but look at this is very peaked and this is pretty flat. So, these things are also important, like let us say one person, the age, let us say age of the people, you have people from almost every age. So, this is the let us say histogram representing age, and these are various bins, age groups, and let us say this is young adult, this is young, this is let us say middle aged, and this is a middle aged old, and this is old. So, if we look at this, the data looks quite flat. So, which means the people who are viewing your movies, this is the frequency. So, people who are viewing your movies belong to all age groups. Okay? Now, suppose the data would have been in a different form. Then you would have said your viewership is more for the middle aged people. Okay? So, therefore, understanding the pickedness of the distribution is also important. So, what we studied so far is we can study the central tendency, then median, mode, of course standard error we did not do, standard deviation, but these are the typical descriptive statistics you can find out from some software. But finding these values is not important. What I am trying to stress is try to relate it to the real problem. Let us say you have an outlier. Before you apply the algorithm, you have to remove the outlier. Let us say you find that all your data from viewer data is equally distributed among all the age groups. So, why not we make separate models for different age groups. So, such kind of decisions can be understood if you look at univariate data. Look at As I told you, when we talk about a data matrix, if we have the entities here and if we have attributes here, the features. Okay? So, these features and attributes together make your data matrix. Now, suppose here you have, how many features you have? You have F1, F2, F3, F4, F5. So, how these features relate to each other? Now, why should you try to relate the features with each other? We tried relating the features with each other because sometimes the features are too correlated, which means they basically give you the same data. So, in that case you should be able to drop one feature. Besides this observation, they can also lead to certain computational issues. That computational issue is called the multicollinearity issues. So, to know about all this detail in depth, probably you have to take some course on statistics, specifically on multivariate statistics. But anyway, that is not important here, because most of the things you will be actually doing using some available code which your specific software or language provides, language library provides. But here the point that I am trying to make is the metrics, the statistics which you are trying to use to represent this relationship. One is your covariance. So, if your matrix, this data matrix, let us say this data matrix, there are m number of users and n number of attributes. So, to show the relationship among the attributes, you will be computing covariance considering any two attribute together. So, if remember the formula for variance, what did you do while trying to find out the variance? It is the spread with respect to a single variable. So, the formula was like this. Now, you have another variable y, x, and along with that another variable y. So, here when we consider two variables, let us say this is variable x, this is variable y, and these are the data points. Looking at the data points, you see what does it indicate? When the variable value of x increase, y increase as well. So, most of the data follow this relationship. So, as value of x increase, y increases too. So, this is a positive relationship. This is a, oh sorry, this actually probably I made a mistake. So, these points would have been like this. This again the positive one is shown as negative point. So, this is the negative relationship. Suppose the points would have been like this. This would be the negative relationship, and here you cannot say anything about the relationship. So, this is a neutral relationship. Moving ahead, if we have total m number of attributes, then we have connecting one variable with another, we have a m cross m covariance matrix. Okay. And what is x here? X is the data matrix, x bar is the individual mean, and this is a basically mean centered data matrix, and we find out the covariance. When we find out the covariance, the diagonal elements are relating one variable with itself. So, they are variances. This covariance matrix is symmetric and it is a positive semi-definite matrix. And what is a positive semi-definite matrix? Which satisfies this criteria. All the eigenvalues must be real, eigenvectors correspond to different eigenvalues are orthonormal, all the eigenvalues are greater than or equal to 0. So, this relationship, as we move ahead to study about dimensionality reduction, this we will be knowing more about it in detail. Now, from covariance, the problem with covariance is covariance can only say whether the relationship is positive or negative, but it cannot say to what degree they are related, how much positive and how much negative. Okay? So, in addition to covariance, we use another measure called correlation, which is basically the normalized value of covariance. And how the covariances are normalized? By dividing by root over of variances. So, this as a result of this normalization, value of correlation lies between -1 to +1. So, looking at how negative, how it is away from the 0, you say how much negatively they are correlated. -1 means completely uncorrelated, and this is fully correlated. This is shows perfect positive correlation, this is a perfect negative correlation, and these are the values where this is highly positive, this is low positive, no correlation, low negative and high negative correlation. So, with this we end today's lecture. These are the references. So, this, if you would like to know more, this is quite a good book, chapter 2 probably or chapter 4 of these fundamentals of quality control in a very lucid manner. It gives you the fundamentals of statistics as well, the statistical background, but there are many statistics good books, but basically I draw certain things from here. And Han and Camber, not the recent one, old version also you can get little detail, and I also got various stuffs from different contribution slides from different other authors. So, to conclude, data can be structured or unstructured. Unstructured data needs to be brought to a structured form for analysis purpose. Data description helps us understand a data set's main features and characteristics, and it helps us identifying the patterns, trends, etc., so that we can gain further insight from the data. So, univariate analysis considers one feature at a time, whereas bivariate analysis finds the relationship among the variables. With this, we end this lecture. Thank you, everyone.